Hello dear students, welcome back to Happy Learning. Today we are going to learn the two concepts. One, it is a formula, and the other one, it is a theory. It is the introductory part for the exercise 2.3 from Polynomials class 9. So once we understood these two concepts, so it is very easy to solve the exercise question. Okay, so let us check. First one, we have to learn what is division algorithm, and secondly we want to know what is remainder theorem. So these two concepts today we are going to learn. Okay, so first of all we will check what is division algorithm. Division algorithm, to clear this concept I am taking one example. Suppose 15 divided by 2. If we are dividing 15 with 2, 15 divided by 2 if we are doing, we know 2 is not going in 1, so we are taking how many times? 7 times, that it is 40, and balance it is 1. So when we studied the division first itself, there we are familiar with the four terms, which are this is the dividend, this is the dividend, this is the divisor, this one is the quotient, and this one is the remainder. Okay, these are the four terms which we are using in division normally. Okay, so here this is the quotient, this is the remainder, dividend and divisor. Now this way if we are writing this 15 by 2, we know this is a fraction, and which type of fraction it is when the numerator is bigger. Which type of fraction? We studied several types of fraction, proper fraction, improper fraction, mixed fraction. So which type of fraction, which category this will come? This is an improper fraction. Why this is an improper fraction? Because the numerator is bigger than the denominator. So whenever the improper fraction, if it is coming, this improper fraction we can only convert into mixed fraction. And what is the process? This is the process. So after division, this is improper fraction, this is an improper fraction, this is an improper fraction, and this we can convert into a mixed fraction. And mixed fraction, 7 is there, 1 is there, 2 is there. Okay, so which way we can write? 7 is the whole part, complete way we got, so 7, and this is remainder. So, and what we are dividing by 2. So this is the way. Actually this is improper fraction, and this is the mixed fraction. Mixed fraction. Both when we are looking appearance it is different, but both the numbers or both the digits, its value it is what? Same. 15 by 2 is equivalent to 7 whole 1 by 2. Okay, so improper fraction we can change into mixed. This is the process. Now it's reverse. How we can change a mixed fraction into improper? That also we know which way we can change. So like this way we can change. 2 into 7 plus 1. This is the way we are doing. No, this is the way we are doing. 2 into 7. First we are multiplying that, so we are getting 14. 14 plus 1, that is 15, and 15 by 2. That is, the denominator is always 2. Divisor don't forget to take. Okay, so this is the process to reverse it. Okay, so actually what it is this here? Dividend is equal to, so dividend is equal to 2, it is what? 2, it is divisor into 7, it is what? Quotient, plus 1, it is what? It is the remainder. This formula already we know. Formula we know, but its name we not know. Its name it is what? Division algorithm. Dividend is equal to divisor into quotient plus remainder. This is actually what? Division algorithm. How to divide the numbers we know. but this chapter is polynomial, so how to divide the polynomials, that also we have to know. So let us divide two polynomials. Here 3x square plus x minus 1, it is the dividend, and x plus 1, it is the divisor. So let us divide. 3x square plus x minus 1, that we have to divide by the divisor, that is x plus 1. Now normally numericals, how we are dividing, the same process, but here it is a polynomial, so carefully we have, because in each polynomial's terms, variables, powers, sign, everything it is there, so we have to take care about that. So let us start. X in 3x square, how many time it is going, that what we have to check first. So if we are taking here 3x, now you just look, this everything we can do as mind calculation. X into 3x, so 3x square we are getting. Exactly the same number itself we have to get. Now the multiplication not over, because this is a polynomial, with x only we multiplied, with 1 multiplication is still there, so we have to multiply that also. So 3x into 1, that is 3x itself, so that we have to write positive positive, so the ultimate side is plus. Okay, so the multiplication is over. Now as usual way, in numbers also what we are doing the subtraction. So here also we have to do the subtraction, but small change it is there. Here there is no one single number is not there. Here this full, it is a polynomial. So when we are doing the subtraction, that subtraction is common to both. Both the terms, it is common. So we have to distribute that subtraction sign. In short, after subtraction, whatever the signs are there in the polynomial, its opposite signs are coming. Okay, so here we are doing the subtraction, so this is negative, and here also negative it is coming. Why? Because already they are existing positive sign, so it's opposite sign. Okay, so negative. Now you just look, now we have to do the subtraction. This is positive 3x square, this is negative 3x square, so this both will be cancelled out. Now here we have to do the subtraction, because the signs are different, so when we are subtracting, here we will get negative 2x. Now also the division is not over. Now we got the first remainder only, but the question is not finished. In question, each and every term we have to give the chance. Here negative 1 we not given the chance. Now next we have to put it down, that negative 1, and again we have to select the quotient in which number this is going. Okay, so here negative 2x is there, here x alone it is there, so we can take negative 2 here. Negative 2 we can take there and start multiplication. Negative 2 into x, that is negative 2x. Negative into positive, again negative. Multiplication answer it is 2. Now subtraction, here we have to do subtraction, so sign changing, then this 2 eliminated, here we will get 1. So now in question there is no other term, all the 3 terms we given the chance, so this is the remainder, this is the remainder. So this is the way we have to do the division of polynomials. Okay, now the division algorithm, it is satisfying in polynomials also, that also we have to check. So division algorithm, we know dividend is equal to divisor into quotient plus remainder. Now dividend is 3x square plus x minus 1 equal to divisor x plus 1, quotient 3x minus 2 plus remainder, it is 1. Now this side, nothing we have to do, we have to solve this side. Binomial into binomial, we have to multiply. X into 3x, first we have to multiply, so 3x square, x into negative 2, that is negative 2x. Multiplication with x is over. Now move on to 1. 1 into 3x, that is 3x, and the sign it is plus. 1 into 2, that is 2, sign it is negative. These 2's multiplication is over. Now plus 1 as it is we have to put. Now this we have to simplify. Like terms, if it is possible, we can add or subtract. 3x square, no other terms similar to that. That means variables have to become same to same, then only it is like terms. So 3x square, these two are the like terms. When we are adding here, addition is not possible because the signs are different, so we have to subtract. So we are getting positive 1x. Now these two are the like terms, they are constant terms, so here there also we have to subtract, so we are getting 1. Now you just look here, the dividend is 3x square plus x minus 1, and the RHS also 3x square plus x minus 1. So here LHS is equal to RHS. That means the division algorithm is also satisfying in polynomials division also. Okay. Now here one more example we are taking to check how to divide the polynomials. This example is there in our textbook given, this example. Okay, 3x raised to 4 minus 4x raised to 3 minus 3x minus 1, that we have to divide by x minus 1. Here the dividend, it is the highest power, it is 4, and for divisor it is a linear polynomial, both are polynomial. Now how to divide, that what we are going to check here. Before that, whenever you are doing the division process, you have to look in dividend the polynomial is in standard form or not. Now you will ask, what is the standard form? Standard form means the polynomial should be in order. Order means its power should be in descending order. Here the highest power first came 4, then 3, then have to come 2, power 2. But that term it is missing here, it is not there. Okay, then came power 1 and power of 0. Okay, so here power 2 it is missing, so that we have to substitute there. Okay, that we have to substitute first itself, and we have to continue the process like this way. 3x raised to 4 minus 4x raised to 3 minus 3x minus 1. Actually this is the question, but when we are doing the division, here power 2 it is missing, no, so that we have to compensate with 0x square minus 3x minus 1. Okay, so maybe some persons are asking, it is compulsory to write like this way. It is not compulsory. Okay, why we are writing like this way? In order to avoid the mistakes in the process, because the process is lengthy. Okay, many steps are there. In each steps terms are there, variables are there, signs are there. So to avoid the mistake only, we are just filling that place. Okay, so we return the polynomial in standard form. Now we are starting the division. X minus 1. Now as usual way, when we are getting 3x raised to 4, when we are taking 3x cube, that time we are getting 3x raised to 4. X into 3x cube, that is 3x raised to 4. 3x cube into negative 1, that is negative 3x cube. Okay, now subtraction time, signs are changing. So this is changing like this way. Then these two eliminated because same numbers are same, signs are different. So here 0 will come. It is not compulsory to have to write there 0. If you are writing 0 there, it is not wrong, no problem. Now next we have to do, here we will get negative 1x cube plus put the next number down. Next we have to check when we are getting x cube, negative x cube, here positive 1x only, so negative x square. So we are getting x cube here, negative into negative, that is positive 1 into x square, that is x square. Then subtraction, so subtraction time, signs are changing, this 2 eliminated, here we will get negative x square. Now give the chance to the next number, that is minus 3x. Next we have to think when we are getting x square. Here 1x is already there, we need negative also. So negative x we will take, negative x. So x into x square, positive and negative, that is negative. Negative into negative, that is positive, and x will come. Signs are changed, this 2 eliminated, here we will get negative 4x. next number, that is minus 1. Now when we are getting minus 4, so minus 4 we have to take here x into negative 4, that is negative 4x, negative into negative, that is positive, 4 into 1, that is 4. Now subtraction, signs are changing, this 2 eliminated, and here we got 5, and this is the remainder. So this is the way we have to do the division of polynomials, and this division process is known as long division method. Here we got the remainder. Okay. Now to avoid this step, okay, and directly we will get the remainder. Okay, suppose if they are asking find the remainder of this division, find the remainder of this division. Okay, so they are asking only the remainder. We don't want the quotient, and these all steps we can avoid. How? Let us look. What is the divisor? It's a 0 of the polynomial. We have to take x minus 1 is the divisor. What is the 0 of the polynomial? That is positive 1. That positive 1 we have to substitute in the question. That means in the dividend. So we are substituting that. Suppose p of x, that is equal to the question, that is 3x raised to 4. This all for your understanding only I am writing. Directly also we can substitute 3x raised to 4 minus 4x cube minus 3x minus 1. This is our question. Now divisor is x minus 1. It's a 0 of the polynomial. It is positive 1. That value we have to substitute throughout. So we will get 3 minus 4 minus 3 minus 1. Positive 3 and negative 3 cancel out. Then what is balance? Negative 4 and negative 1, that is negative 5. This is the remainder. Okay, and here you just look, both the remainders are same. Okay, here this much time we taken to find out the remainder. Here within seconds we got the remainder. Okay, so this method is quite easy, no? Actually this is what the remainder theorem. Okay, this is what the remainder theorem. This theory helps us to find the remainder within seconds. Okay, and the method is also very easy. Once again, in short, I am saying what is remainder theorem? Remainder theorem means in division, which one is the divisor? Which one is the divisor? Take its 0 of the polynomial and substitute in the question. So you will get the remainder. Okay. Now we are going to learn the remainder theorem and its proof. That theorem which way given in our textbook, that is here. Let p of x be any polynomial of degree greater than or equal to 1 and a be any real number. Okay, so that means if we are taking a polynomial for division purpose, if we are taking any polynomial, its power can come as 1. That means it can come as linear equation, or greater than that. That means quadratic, cubic, like that way. Okay, just previous example we did 3x raised to 4. Okay, so like that way. So that is the first condition what they are giving. The dividend's power, it can come as 1 or greater than 1. Okay, then a be any real number. That means in when we are taking the divisor, it is a linear polynomial. No? So x is the variable, a can be any digit. Okay, and in that case, what is the remainder we are getting? We are getting the remainder as p of a. Here x minus a is here. So what is the remainder we are getting? It is p of a. So that is the remainder theorem. Now let us check its proof. Proof. So the algorithm, division algorithm, we are writing dividend is equal to divisor into quotient plus remainder. This is the division algorithm. Now we are substituting here. This is in general, so we are taking dividend as p of x. It is a polynomial. Divisor they given, that is what, x minus a, that is the general form. X is the variable, a can be any real number. Quotient we not know, so that also we are considering as q of x, and remainder we not know, so we are taking as remainder as r. Okay. Now P of X, as it is we are writing, we have to substitute A. So P of A equal to A minus A. Where is X? There we have to substitute A into Q of X, or instead of this into, we can use the bracket also. Brackets mean it is into itself, no? So A minus A, and here plus R is there. A minus A, it is 0. Same numbers, if we are subtracting, result is 0 into Q of X. So 0 with any of the number, if we are multiplying, this full becomes 0, no? So 0 plus R is there, remainder. So here P of A equal to 0 plus R means what? Remainder itself, no? So this is the proof for remainder theorem. So in today's class, we studied what is division algorithm and the remainder theorem. I hope you understand the concept clearly. Now we will meet in the next class. Okay, thank you.